to JMath.
Let's do a few questions where you now need to decide is it sine rule, cos rule, and how on earth you're going to get to the answer they are looking for. Question 1. In the accompanying figure, CD represents a vertical cliff face. At the point A, in the same horizontal plane as the foot of the cliff, the angle of elevation to the top of the cliff is 36 degrees. Okay, so let's stop there for a moment. If they tell you something about the angle of elevation, please always remember you are standing on the ground and you are looking up at something high. So point A is where a bystander or someone is standing, and they need to tilt their head backwards 36 degrees to see the top of this cliff. That's why it's called the angle of elevation, because you're looking up. In other questions, you might hear the phrase angle of depression. So that's if you high and you're looking down on something. So don't get confused by that words. It just means you're looking up or you're looking down. Okay, at a point B, 380 meters closer to the cliff, and also on the same horizontal plane, the angle of elevation to the top of the cliff is 44 degrees. Find the height of the cliff, correct, to the nearest meter. Okay, so first we need to do a little bit of analysis. So I know that I need to end with CD. In triangle CD, I have a 90 degrees and I have a 44 degrees, but I don't have any sides, so I can't start there. Normally with these questions, you need to start as far away as possible from what they are actually guiding you towards. So I'm going to start with triangle ACB to get my answers. Now, in that triangle, I have a 36 degrees, I have 380 meters, and I also have the exterior angle of the triangle. So my first step in this case would be to say, I know that angle ACB would be equal to 44 minus 36. Now, for those of you who don't remember where this comes from, that says the exterior angle of a triangle is always equal to the sum of the opposite interior angles. So this would just be 8 degrees. Now I have 3 sets of info in that little triangle, and therefore I can use the sine rule or the cos rule to work something out. So let's just color code a little bit. I can see the 8 goes with the 380. Okay, so there I have a couple. So I know I'm going to use sine rule. The 36 now goes with CD. So I have enough info to say BC over sine 36 is equal to, then I started with the side, so I must start with 380 over sine of 8 degrees. Perfect. Now I can just multiply over the sine 36 and then type everything in the calculator to find the length of BC. So this is just sine 8. Sorry, I stopped color coding. It just takes a little bit too long. So if I type all of that in the calculator, I see the answer is 1604.8963 dot dot dot. Very important. They didn't ask me for the length of BC, so I must keep the entire answer on my calculator and not round off to avoid mistakes. Now I'm into the triangle that is actually where I want to be. And I know that purple side is 1604. Now I need to see what am I going to use there. Now you can always go back to grade 10 if you see a 90 degree. So I can use sine, cos, and tan, opposite, adjacent, and hypotenuse to work this out. So I'm looking for the opposite, and I have the hypotenuse. So I can actually use sine in this case, but I know many students, especially grade 12s, tell me I just want to stick to sine rule and cos rule. That is 100% your choice. So in this case, if I just stick to sine rule and cos rule, I can say I am looking for CD. So in this case, if I color code, CD goes with the 44 and the purple side goes with the 90 degrees. So always start with what you want to work out, and I want to work out what CD is. So CD goes over sine 44, and that will be equal to the purple couple that I have. So I started with the side. I then need to say 1604.89 dot 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 over sine 90. Now I can just multiply over the sine 44 and type all of that in the calculator to see what they give me. The question asked me to round off to the nearest meter, so I can just say that answer is 1,115 meters. So guys, please use your highlighters, see where the couples are and what you can pair together. Otherwise, this is going to be really tricky. Now, I know in the finals, you're not allowed to use highlighters in some schools. But please, while you're practicing, practice with colors. It's just going to make it so much easier. Let's look at question 2. You can read the sentence up top. They told me everything that I need to know. I must just note that there's an angle that's bisected. So those with the double arches are actually equal in size. Question 1, show by calculation that x is 60 degrees. I can go and see what I have in the triangle that includes the x, and I can actually, again, use my grade 10 trig because there is a 90 degrees. So guys, you can make this easier for yourself. I'm just going to follow the sine rule, cos rule method, but that is not the easiest way in this case. I can see that x is green and it goes with 4 root 3 as its opposite side. Then I have the purple couple, so I can use the sine rule. So x is actually an angle, so I need to start with sine x over 4 root 3 would be equal to sine 90 over 8. And I can just multiply over and then say sine x will be equal to 4 root 3 over 8. sine 90 is actually just 1. So now to get x, I can just shift sine this answer, and this answer would give me 60 degrees if we're working with sine. Perfect, I answered question 1. If I just complete my triangle, I now know that x is 60, and therefore the other angle in that right angled triangle must be 30 degrees. Now, they also told me that this angle is bisected, meaning the bottom part is also 30 degrees. So now, to start question 2, calculate the length of AD. I am now looking at the bottom triangle, so I just need to color code again and see if I have a couple or if I don't. So the 8 is purple. It goes with angle D. I don't know what angle D is. The 4 I made blue. That goes with angle Y. I also don't know angle Y. And then the 30 goes with side AD, which I also don't know. So in this case, I have two sides and an included angle, which leads me to cos rule. If I do the cos rule, I need to start with the side opposite the angle I'm going to use. So in this case, it works out nicely. I want AD squared, and that will then be equal to the 4 squared plus the 8 squared minus 2 times 4 times 8, and then cos of 30 degrees. So then AD would be equal to the square root of 24.5743 dot dot dot. And then I just type it in my calculator, and then I am allowed to round off to 2 decimal places. According to my calculator, that is 4,957, but I can round off to 2 places, so 4,96. I don't know if it's meters or centimeters, so I just need to write units. Now for question 3, they want me to work out what is y, and if I just go with my colors, I can see y is blue, and it goes with the 4, so I have a couple, and I can then use sine rule. So if I set up my sine rule, sine y over 4 is equal to sine 30 over my previous answer. Now, extremely important, guys. They asked me for the length of AD, so therefore I am allowed to use the rounded version. If they didn't, and they just asked me one question for the sum, determine y, I am not allowed to round off because it wasn't a previous answer that I'm using. Please keep that in mind. So many people lost marks because of something so small. If I then just complete the sum, use my calculator, I see y is 23.78 degrees. The only difference between a grade 12 sine rule, cos rule sum and a grade 11 is that they make it 3D. Now, this sounds very complicated, but in effect, it's really not that hard. As long as you can just visualize the triangles as they are and not get stuck on a 90 degrees. So if you look at this sketch, angle B is in the white triangle. It's perfect 90 degrees, I can see that. But in the other triangle, they try to indicate that there's a 90 degrees in triangle ABE. Because it's a vertical tower, it must be 90 degrees, even though it does not look like that. So that's the only place where 3D trig gets a bit tricky, mind the pun. But just visualize this from all angles and practice a lot. It is not as difficult as it looks at first. Now, with all the info they give me, they just ask me, calculate the height of the tower correct to 2 decimal places. I must now figure out where am I going to start with this thing. So the height of the tower is AB, and that is in the white triangle. But in that triangle, I only know there's a 90 degrees and a 10 degrees. That's not enough for me to actually start this question with. So I am going to have to go to the gray triangle and try and figure out what is the value of the side that links these two triangles, so BC. So that's my first goal. The goal is to get side BC. So that's the blue one. I know the opposite angle. Okay, perfect. But with orange, I don't know the opposite side. But with purple, I can work out the angle with interior angles of a triangle. So that's my first step in the sum. What is the size of angle B? So I can go back to grade 8 and 9 geometry to say the interior angles of a triangle must be 180 degrees. So therefore, I will get angle B if I say 180 minus 44 minus 61. And that would just give me 75 degrees. So now I can put in the 75 degrees and I have enough info to use the sine rule. I want BC, so I'm going to start with BC over sine 44, and that must be equal to, for the purple, 668 over sine 75. And therefore BC will be equal to 480,40 meters. Now that I have the size of BC, I can go to the white triangle, and then I can do opposite over adjacent, so I can use tan in that triangle because it's a 90 degree, or I can use the sine or cos rule again. It is really your choice. Just for the purposes of these videos, I'm going to take the long way, but please, if you see and you're comfortable with the shortcut, please take the shortcut. If I look at the white triangle, I can see I'm looking for the green side. I have its opposite angle, and with the blue, I also have everything I need. So I can say AB over sine of 10 will be equal to 480.40 over sine 80. If I just multiply over, I can see that the length of this vertical tower will be equal to 84.71 meters. So even though it was 3D, I don't think it was too tricky to analyze what's going on here. Let's look at another example to see how you would attempt 3D trig. Question 4, so they give me all the info. Always just check that everything they tell you in the paragraph is indicated on the sketch or vice versa. They are asking me to calculate the length of PQ. So now, you must be sure that you know what's going on here. So there's 3 triangles I can see, and then there's a triangle PTQ in front of those 3 as well. So sometimes they ask you questions about all of the triangles. In this case, I think it's a little bit easier. So I need to end with side PQ in the gray triangle. But I can't start there because I only know the 37 degrees. So I'm actually going to start with the 31 degrees in that white triangle top left. In that triangle, I can see I have a 90, I have a 31, and I have a 33. So let's use our highlighters to see if it's sine rule, cos rule, or if I can just use grade 10 opposite, adjacent, and hypotenuse rules. I can see that I have, with blue, I have the 31 and the 33. So they go together. And then with the purple, I don't have its opposite angle, but there's a 90 degrees. So I can just work out the opposite angle with interior angles of a triangle. So then I can say angle T must be equal to 180 minus 90 minus 31. And that just gives me 59 degrees. So now I have everything for purple. And I can work my way towards the gray triangle by finding PR, the side that links the 2 triangles. I'm going to use the sine rule because I have a blue couple and one other value. And my calculator tells me this is 54.921 dot dot dot. Remember, not allowed to round off because it's not what they are actually asking for. Now I can move over to the gray triangle, and I know this value I just found is PR, but they're indicating that it's also RQ. So that's going to help me a lot, and then I can work my way towards finding PQ. So those lines indicate that the 2 sides are the same, but it also tells me that the 2 angles are the same. So Q is also 37 degrees, and that would help me to figure out what is angle PRQ. So let's do that. If you get stuck with a 3D sketch and it looks so cluttered and you can't fill in values, please redraw the triangle just like I did now. So I just redrew PTQ and I did it big enough so I can fill in and work things out, and then my brain is not as cluttered as if it would be if I just worked on that one sketch. So with that, I saw that angle T is actually 106 degrees, and now I have the option to work with sine rule or with cos rule. So just because in this video we almost never work with cos rule, let's take that option to show you exactly how it would work. So I want PQ, so I'm going to start with PQ squared is equal to, the reason I can do that is because I know the opposite angle. I know I'm going to end with cos 106 degrees. Now, so with the other 2, it really doesn't matter in which order you write them, especially with the isosceles triangle, because they are exactly the same. So I'm just going to fill that in according to the cos rule. By using the cos rule, I could then see that PQ is actually 87.72 meters. So all of the sums we attempted now had numbers in them. I knew the sides in meters or in units, and I knew the angles. In the next video, when they try and trick you and make it exam level difficult, then they take away all the numbers and you just need to prove the concept that they give you. So it gets a bit tricky, but let's try it. You don't know in exams which one you're going to get, one with numbers or one without numbers.
If this video helped you, please like and subscribe.
JMath.